control, ownership, attestation, and the cryptographic proof security model. Every Bitcoin transaction requires a valid signature to be included in the blockchain, which can only be generated with valid digital keys. Therefore, anyone with a copy of those keys has control of the Bitcoin in that account. We know that the keys come in a pair of private and public keys. These digital keys are very rarely seen by the users of Bitcoin. For the most part, they are stored inside the wallet file and managed by the Bitcoin wallet software. In the payment portion of Bitcoin transaction, the recipient's public key is represented by its digital fingerprint, called a Bitcoin address, which is used in the same way as the beneficiary name on a check where we say pay to the order of. In most cases, a Bitcoin address is generated from and corresponds to a public key. The Bitcoin address is the only representation of the keys that users will routinely see, because this is the part they need to share with the world. When talking of wallets, we need to understand how keys are generated, stored, and managed. We need to understand various encoding formats used to represent private and public keys, addresses, and script addresses. Finally, we will look at special use of keys to sign messages, to prove ownership, and to create vanity addresses and paper wallets. We have already covered cryptography. Let us look at the cryptography along with cryptocurrency. Public key cryptography is a mathematical foundation for computer and information security. These mathematical functions are practically irreversible, meaning that they are easy to calculate in one direction and infeasible to calculate in the opposite direction. Based on these mathematical functions, cryptography enables the creation of digital secrets and unforgeable digital signatures. In Bitcoin, public key cryptography is used to create a key pair that controls access to the Bitcoins. The key pair consists of a private key and derived from it a unique public key. The public key is used to receive Bitcoins and the private key is used to sign transactions to spend those Bitcoins. There is a mathematical relationship between the public and the private key that allows the private key to be used to generate signatures on messages. This signature can be validated against the public key without revealing the private key. When spending Bitcoins, the current Bitcoin owner presents her public key and a signature, which is different each time but created from the same private key in a transaction to spend those Bitcoins. Through the presentation of the public key and signature, everyone in the Bitcoin network can verify and accept the transaction as valid, confirming that the person transferring the Bitcoins owned them at the time of the transfer. In most wallet implementations, the private and public keys are stored together as a key pair for convenience. However, the public key can be calculated from the private key, so storing only the private key is also possible. The diagram shows the generation and the relationship clearly. Private key. The Bitcoin private key is just a number. You can pick your private keys randomly using just a coin, pencil, and a paper. Toss a coin 256 times and you have the binary digits of a random private key you can use in a Bitcoin wallet. The public key can then be generated from the private key. It would be beneficial for students to read and understand how the random number for private key is generated. Public keys. The public key is calculated from the private key using elliptic curve multiplication method, which is irreversible. Public key represent as capital K is equal to a lowercase k star g, where lowercase k is the private key. G is a constant point called the generator point. The reverse of calculating private key from the public key is not possible. The relationship between private and public keys is fixed, but can only be calculated in one direction, from private to public. That is why a Bitcoin address derived from public key K can be shared with anyone and does not reveal the user's private key, which is lowercase k. We have already covered the types of wallets. Let's look at the classes of them. Non-deterministic or random wallets. In the first Bitcoin client, wallets were simply collections of randomly generated private keys, also called type O, non-deterministic wallet. For example, the Bitcoin Core client pre-generates 100 random private keys when first started and generates more keys as needed, using each key only once. This type of wallet is nicknamed just a bunch of keys or JBOK. They are cumbersome to manage, backup and import. The disadvantage of random keys is that if you generate many of them, you must keep copies of all of them, meaning that the wallet must be backed up frequently. Each key must be backed up or the funds it controls are irrevocably lost if the wallet becomes inaccessible. The above conflicts directly with the principle of avoiding address reuse by using each Bitcoin address for only one transaction. Address reuse reduces privacy by associating multiple transactions and addresses with each other. Next is deterministic or seeded wallets. These are the wallets that contain private keys that are all derived from a common seed through the use of a one-way hash function. The seed is a randomly generated number that is combined with other data such as an index number or chain code to derive the private keys. In a deterministic wallet, the seed is sufficient to recover all the derived keys and therefore a single backup at creation time is sufficient. The seed is also sufficient for a wallet export or import, allowing for easy migration of all the user keys between different wallet implementations. As we see, the seed is an important aspect of any deterministic wallet. So how is this seed generated? I will introduce another term, namely mnemonic code words. So what are these mnemonic code words? They are English word sequences that represent a random number used as a seed to derive a deterministic wallet. The sequence of words is sufficient to recreate the seed and from there recreate the wallet and all the derived keys. A wallet application that implements deterministic wallets with mnemonic code will show the user a sequence of 12 to 24 words when first creating a wallet. That sequence of words is the wallet backup and can be used to recover and recreate all the keys in the same or any compatible wallet application. Mnemonic code words make it easier for users to back up wallets because they are easy to read and correctly transcribe, as compared to the random sequence of numbers. Mnemonic codes are defined in Bitcoin Improvement Proposal 39, which is also known as BIP 0039, which is currently in draft status. It is not a standard yet. BIP 0039 defines the creation of a mnemonic code and seeds as follows. Create a random sequence entropy of 128 to 256 bits. Create a checksum of the random sequence by taking the first few bits of its SHA-256 hash. Add the checksum to the end of the random sequence. Divide the sequence into sections of 11 bits, using those to index a dictionary of 2048 predefined words. Produce 12 to 24 words representing the mnemonic code. The table shows the relationship between the size of entropy data and the length of mnemonic codes in words. The figure shows some examples of mnemonic codes.